Hi, this is Miss Claywell with 12.3, and we're going to be talking about rationalizing radicals and simplifying them. So if you look at the top of your 12.3 notes, I'm going to take a second to think about what is square root of 3 times square root of 3 and square root of 5 times square root of 5. So that becomes the square root of 9, which is 3, or we can think of this as square root of 3 squared. The squared and the square root cancel each other out, equals 3. Same idea over here. This is square root of 25, which is 5. We can think of it as 5 squared, which is 5. So the square roots undo each other. And when we see a square root in the denominator, we don't want that. That's not ideal form. We want to get rid of the square root in the denominator by rationalizing. So we're going to talk about rationalizing and getting rid of whatever is the square root or the root in the denominator. So here, I do not want this 5 in the denominator. So the denominator is square root of 5. Multiply the top and the bottom by what you found in the denominator. So if I want to multiply the denominator by negative square root of 5, I also have to do that to the numerator. So you can think of this as like a fancy one. That's the same as like square root of 5 divided by square root of 5 is 1. So I'm just changing the form. You think of it as this becomes 6 square root of 5. Square root of 5 times square root of 5 is 25. Or you can just think of it as the square roots go away and it's 5 on the inside now. So my fancy one, wherever the denominator is, I want to multiply the numerator and the denominator by that. Okay, let's try these. So I'm going to do square root of 3 over square root of 3. I'm just going through and thinking of my fancy ones. Think about what you need in the numerator. So whatever my denominator is. Six square root of 3 over 3. And 6 divided by 3 is 2, so I can simplify that more. 2 over 5, I can't simplify more. That becomes a square root 7. Go ahead and flip to the back page. So we're going to talk about this pattern. You can double distribute or box, whatever makes most sense to you. And square root of 3 times square root of 3 is negative. I have a negative, so it's negative square root of 9. These would cancel each other out. This would become a minus 3. So I get a 13. So notice the only difference is I had a negative and a positive in the middle. Let's see if that pattern continues here. So 49 minus 7 square root 5, or plus 7 square root 5 minus 7 square root 5 minus square root 25. Those would cancel out. I get rid of the square root. 49 minus 5 is 44. So notice if the inside has the opposite sign, I get rid of the square root. These relationships between the two are called the conjugate. So conjugate, and they have opposite signs. So we're going to keep this in mind as we look at the last part. So notice here, I just can't do like a square root of 5 or a square root of 1. Because I have a plus, a number plus a square root, I have to use the conjugate, so I keep it, and the opposite is 4 minus with a minus. So I want to multiply my numerator and my denominator by that. Again, this is like a fancy 1. And I can think of my numerator and my denominator. I can distribute that 6, so I get 24 minus 6 square root 5. 16 minus or plus 4. Oh, no, sorry. And now I can work to simplify that. So if you can show less stuff, that's fine. My numerator, I can't really simplify anymore. Keep in mind, these are always going to cancel out. And I get 16 minus, and that's like a 5. And look, I no longer have a square root in my denominator, which was my goal during this. So I no longer have a square root in the denominator, which is exactly what I wanted. Okay, I want you to take a second and just write the conjugates for each of these. So you do the opposite of the inside, like your fancy ones. Whatever you do to the numerator, you have to do the denominator. So just go ahead and take a second, look at these. Double distribute. And then 16 minus 4 square root 3 plus 4 square root 3. And if you can show this in less steps, that's fine. Remember, the roots always cancel out. We end up with a 16 minus square root of 9, which is the same as like a 3. And we got rid of our square root. Same idea over here. Distribute the 2. And then double distribute. So you can box or double distribute the bottom. Yeah, but it's helpful for you to think of these as in parentheses. So remember, this is the same as like a minus 5. And then 6, 2, and 4, I can divide all them by 2. So I did each of those by 2. Last one here. My numerator and my denominator both have double distribution. I'm going to do my denominator first. If it's easier, you can just write minus 7 when you see the square roots are going to go away. Here I double distribute 28 minus 7 square root 7 minus 4 square root 7 plus square root 49. So these two cancel out, and these can be combined. Ooh, not 13, that's an 11, my bad. So it is okay to have a square root in the numerator, we just can't have it in the denominator. So these two could combined and these two could combined. Okay, I'm happy to answer questions when I am back in class.